Hello everyone, this is Mr. Regner and this is our topic for assessment practice. You're going to find this starting in your workbook on page 171. So I thought what I'd do here is make a video just kind of going through all those questions so that you can use this video as you review for your test and kind of prepare yourself. Keep in mind on the video you can always skip ahead, you can watch things more than once, you can stop them, pause them, you could even fast forward or rewind the video in whatever you need to do to help yourself out most. So let's go ahead and get started here, taking a look at question number 1. It says a credit card is 76 hundredths millimeters thick. How thick is a stack of 10 to the third power credit cards? And explain. What? Well, I would write this down. We have 76 hundredths thickness here, right? Millimeters thick. So if it is 10 to the third power, I'm multiplying it, right? If I have, like, let's say 2 of them, that's going to be times 2. 3 of them times 3. I have 10 to the third power. Now remember, 10 to the third power breaks down as 10 times 10 times 10. We might know that 10 times 10 times 10 is also a 1 with 3 zeros, or 1,000. So we really are looking at 76 hundredths times 1,000. Now keep this in mind. Whenever you're multiplying, we're going to go ahead and, if these were whole numbers, we'd add a 0 to the end, or in this case, 3 zeros. Since we have the decimal, we can think that we're moving that decimal over to the right 3 times. So let me just write this out. If I move my decimal over to the right, look, 1, 2, 3 times. The decimal is now here. And let's see if I can do this. Erase that decimal, add a 0 in. That means my answer is 760. It's 760 millimeters thick if I had a giant stack of credit cards. That's number 1. Take a look at number 2. It says Leo has 59 bricks each, measuring 19 hundredths meters long. He lines up the bricks to make a row. So picture that in your head for a moment. Letter A says estimate the length of Leo's row of bricks and write an equation to model your work. Well, let's see. There's 59 bricks, each measuring 19 meters long. Now, if I draw a picture of this, like there's a brick, a brick, a brick, a brick, I would draw 59 bricks, right? Each one of them would be, 19. So I could do like repeat addition, 19 hundredths, 19 hundredths, 19 hundredths, 19 hundredths, 19 hundredths. Or, because we know that we're just doing repeat addition, we could also multiply. That's 59 times 19 hundredths. But letter A is very clear. It says estimate. So I'm not going to use 19 hundredths. I'm going to round that. And I'm going to say that's about 2/10 or 20 hundredths. Right? I'm going to also round 59 and maybe bump that up to 60. So now I have 60 times 2/10. That's something we might be able to do right inside of our own heads. Right? Just think 60 times 2, and then the decimals moved over 1 space. 60 times 2 is going to equal 120. And there should be a decimal over 1 space. That means my answer is 12. Now that is my estimated answer, right? Because I did some rounding. Part B says find the actual length of the row of bricks. So I'm going to go back up here. Let's see if I can. I'm trying to be all fancy here with my tablet. Getting all fancy on you. All right, I'm going to take my actual numbers now and multiply them. So I'm going to use my rules for multiplication, the shortcut that we've learned, where we ignore the decimal and multiply as if these are whole numbers. So 9 times 9 is 81. 9 times 5 is 45, plus 8 is 53. Add a placeholder 0, 1 times 9, 1 times 5. Add the numbers together. We end up with 1. Let's see if you can see it. 1, and then 9 plus 3 is 12. 5 plus 5 is 10, plus 1 is 11. We get 1121, but wait, don't forget about your decimals. There's 1 space, 2 spaces after that decimal, So I need 1 space, 2 space, put my decimal right in the middle. My answer is 11 and 21 hundredths. That's pretty close to our estimate. Our estimate was 12, but obviously we overestimated. Let's take a look at number 3. Number 3 says, Susan colored in the decimal grid shown below. Write an expression that shows the area she colored, then evaluate the expression. Well, let's take a look at it here. So we've got my fancy tablet getting all funky on me here for one thing. There we go. All right, we have the grid. Now there's 10 blocks this way and 10 blocks this way. She colored in just this little yellow portion that you see here. So I'm going to see here, I have 3 blocks, 1, 2, 3. And on this side, I have 1, 2, 3, 4, 5, 6, 7, 8 blocks. So I can use the expression 3 times 8. That's going to tell me the area here. Now I could obviously count all those yellow blocks, or I could just do 3 times 8. That equals 24. Now if that's true, I should count 24 blocks. And I'll kind of do it really quickly. Yep, there's 24. So we would just write 3 times 8 equals 24. Not too bad. Let's move on. Take a look at number 4. Now number 4 is kind of a tricky one in the fact that we've got 4 different questions and 4 different answers. We've seen questions like this before. It says match each expression on the left with its product. So I'm going to take it one step at a time here and just look at this first one. It says 5 times 8 hundredths. So I'm going to set that up and multiply as I normally would. I'm going to keep it with my larger amount of digits on the top and multiply ignoring that decimal. 5 times 8 is 40, right? I could put the 4 up here, carry it down, I have a bunch of zeros, but we just get 40. I know there's 2 spaces after the decimal, so I need 2 spaces. So my decimal goes there. I'm looking for 4 tenths. And look, there it is, 4 tenths. I put that as my check mark. The next one is 5 tenths times 8 hundredths. So let me work that one out. I have 5 tenths times 8 hundredths. So I'm going to multiply. 5 times 8 is 40. I have 1, 2, 3 spaces. 1, 2, 3 spaces. I'll fill in a 0 and put my decimal. I get 40 thousandths, or I could kind of scrap this 0 and just call it 4 hundredths. Look, there's 4 hundredths. Look at the next one. We have 50 times 8 tenths. Now for this one, 8 times 0 is 0. 8 times 5 is 40. I have 1 decimal place there, so I have 1 decimal place there, and my answer is 40. Look, there's 40. There's my answer. Take a look at the next one. We have 5 times 8 tenths. So 5 times 8 is 40. I have 1 decimal place, 1 decimal. My answer here is 4.0, or 4 and 0 tenths. I can just call it 4, and there's my answer. So although this may look confusing with the grid, number 4 is actually one that we can all do pretty easily by just solving the problems. On to number 5. Michelle bought 4 6/10 yards of fabric. Each yard of fabric costs $4.95. How much did Michelle spend on fabric? Enter your answer in the box. Okay, so we know that there's $4.95 for 1 yard of fabric. I'm going to write that down because that's good stuff. She's not buying 1 yard, she's buying 4 6/10 yards. So we could take $4.95 for 1 yard, $4.95 for another yard, $4.95 for a third yard, $4.95 for a fourth yard, repeated addition. You get my drift. Or make it easy on ourselves and just multiply. So that was 4 6/10 yards. Now again, when I multiply, I'm going to ignore my decimals and just multiply like normal. 6 times 5 is 30. 6 times 9 is 54 plus 3, 57. 6 times 4 is 24 plus 5 is 29. Add my placeholder 0. 4 times 5 is 20. 4 times 9 is 36. 4 times 4 is 16. Plus 3 is 19. Add them together. Can't make a plus sign. There we go. All right, 0 plus 0 is 0. 0 plus 7 is 7. 9 plus 6 is 15. 9 plus 1 is 10. Plus 2 is 12. And 1 plus 1 is 2. We get 22,570, but wait, can't forget about our decimals. Look, decimal space, decimal space, decimal space. We're going to move it over 3 times. Bloop. So there's my answer. Now, remember our label here. It says, how much did she spend? This is actually going to be $22.57 that she is spending on this fabric. We solved it by using math. Take a look at number 6. It says choose all the expressions that are equal to 75 hundredths times 5 tenths. So to answer this question, I'm going to first actually solve that. I'm going to take 75 hundredths times 5 tenths. Then I'll be able to hopefully figure this out. So 5 times 5 is 25. Maybe. There we go. 25. Technology. 5 times 7 is 35, plus 2 is 37. So I end up with 375. But wait, can't forget about my decimals. There are 3 spaces there. So I need 1, 2, 3 spaces. And I put my decimal right there. I end up with 0.375, or 375 thousandths. Now let's look at our options here. Boy, there's so many of them, right? We have 5 tenths times 75 tenths. What? Okay, so if I'm going to multiply these numbers together, I want to make sure that I can multiply them correctly. 5 tenths times 75 tenths. Whenever I'm multiplying decimals, I could potentially cross-simplify. And that's what I'm going to try to do here. So I know that 5 and 10 both have a common factor of 5. 5 goes into 5 once, 5 goes into 10 twice. So now I have 1 times 75, that's 75. And 10 times 2, that's 20. 75 over 20 is an improper fraction. I know there's no way that 0.375, or 375 thousandths, is going to be equal to that. Let me take a look at the next one. We have 5 hundredths times 75 hundredths. Now again, I could cross-simplify. Look, 25 goes into 75 3 times, and it goes into 100 4 times. 5 goes into 100. 5 goes into 5 once. 5 goes into 120 times. So I'd end up with an answer of 3, and then 4 times 20 would be 80. That's 3 over 80. Now I can turn that into a decimal by just dividing. I'll take 3 divided by 80. That means 80 is going to be my divisor, and 3 is going to be my dividend. Obviously, 80 doesn't go into 3, but I can add a decimal and a 0. 80 doesn't go into 30. I can add another 0. 80 does go into 300. So I'll bring that decimal up. We know it doesn't go into 30. 80 goes into 300. I had to think about this one for a second. $80 does go into 300. We'll say 3 times, right? 3 times 8 is 24, so 3 times 80 is 240. I'll subtract. I get a 0. Borrow. 10 minus 4 is 6. 2 minus 2 is 0. So I end up with 60. Add another 0, bring it down. And 80 does go into 600. We'll say 7 times. 7 times 8 is 56, so 7 times 80 is 560. We have a 0. Borrow. 10 minus 6 is 4. Right? And we can keep on going and going and going. We'll add that 0, bring it down. 80 does go into 400. And that would be 5 times. 5 times 80 is 400. We get an answer of 0. So 375 ten thousandths. Remember, we're looking for an answer that's going to be 375 thousandths. So unfortunately, that one's really close. No cigar, though. It's not going to work. Take a look at the next one. We get 75 hundredths times 5/10. So again, cross simplification is a great tool we can use here to make life easier. So 1 times 75 equals 75. 20 times 10 equals 200. 75 over 200. I can again do my division problem. So I have 200 as my divisor, 75 as my dividend. I'd need to add that decimal and bring it up. 200 goes into 750. We'll say 3 times. 3 times 200 is 600. I'll subtract. I get 150. Add a 0, bring it down. 200 goes into 1,500. We'll say, whoops. Oh, that was fun, huh? That went right back to the very beginning. All right, 2,000 goes into 1,500. That'd be 7 times. 7 times 200 is 1,400. We'll subtract. We end up with 100. Add a 0 and bring it down. 200 goes into 1,000 5 times, which is 1,000. We get a remainder of 0. So this one would be correct because we get 375 thousandths. Sorry. Got a couple more over here that I've been covering up. Here we are. We have 5/10 times 75 hundredths. Once again, we can use cross simplification. 5 goes into 5 once. 5 goes into 120 times. Right? We end up with 75 over 200. Does that remind you of anything? Oops. Look, 75 over 200. So we know that's going to break down to 375 thousandths. So we know this one has to be correct. And finally, we have 50 over 100 times 75 over 100. My handwriting is getting sloppier as I go. Oh no. So 50 goes into 50 once, and 50 goes into 100 twice. 25 goes into 75 3 times, and it goes into 100 4 times. So now I have 3/8. Now is 3/8 going to break down? Let's find out. 8 is going to be my divisor. 3 is on the inside. Add my decimal. Bring the decimal up. 8 goes into 30. We'll say 3 times. That's 24. I'll subtract. Borrow. 10 minus 4 is 6. Add a 0 and bring it down. 8 goes into 60. Let's say 7 times. That's 56. I get 4. Add my 0 and bring it down. 8 goes into 40. Oh no. You guys missed out on some amazing math work there. Isn't this awesome how my screen keeps flipping around? It's just great. Okay, so 8 goes into 45 times, and we end up with 375 thousandths. That's what we've been looking for. So again, this option is also correct. So number 6 seems so unimposing, right? It seems like such an easy problem to solve. There's actually a lot going on in number 6. Take a look at number 7. Now number 7 says, select each equation that makes the number 10 squared, or select each equation that the number 10 squared makes true. So in other words, inside that box, we're going to put 10 squared. Okay, now if I multiply anything times 10 squared, I'm just moving that decimal over 2 times. So I'm going to look at this. I have 31 thousandths. If I multiply it times 10 squared, whoop, whoop, I get 3 1/10. That is not going to work. That's 31. If I take 501 thousandths and move it over, whoop, whoop, 2 times, I get 50 1/10. That's not going to work. If I look at 4 8/100ths, right? If I move it over 2 times, bloop, I get 408. That will work. If I look at 97 hundredths, move it over 2 times, I'm going to get 97. That works. And then finally, I have 55 hundredths. If I multiply it times 10 squared, I move it over 2 times, bloop, bloop, I get 55. That's really sloppy. But we can see that 550 is not the right answer. So number 7 could be an easier problem as well. Let's take a look at the next page. Now, I think I've shared this with you guys before, but I'm using an old student copy of a book. I don't know that their answers are correct. So let's not get too excited when we see some answers here in my book. Number 8, it says, Nadia drew a square in her notebook Each side measured 2 5/10 centimeters. Look, there it is. What is the perimeter of the square? Remember, the perimeter, we're going to take all of the sides and add them up. There are 4 sides, so we could add all 4 sides. Or, which maybe would make this easier, we could also multiply the length of one side times 4, since we know it's a square. So 4 times 5 is 20, and 4 times 2 is 8, plus 2 is 10. We have one decimal move to make, so we know our answer here is going to be 10 centimeters squared. Or sorry, 10 centimeters for the perimeter. The perimeter equals 10 centimeters. Look at letter B. It says, what's the area of that square? Well, the area, remember, we're going to use our formula. Area equals base times height, or we could say area equals length times width. If we use either one of those formulas, the base or the height, the length or the width, they're all the same. It's 2 5/10. So I'm going to take 2 5/10 and multiply that times 2 5/10. Okay, I'm going to ignore the decimals. I'll just go 5 times 5 is 25. 5 times 2 is 10, plus 2 is 12. Add a placeholder 0. 2 times 5 is 10. And 2 times 2 is 4, plus 1 is 5. Add that together. We end up with 5, 2, and 6. There's one decimal place, one decimal place. Move it over 2 times. My answer there for the area is going to be 6 25/100. And that we label as centimeters squared, because we're talking about area. And you can't really see it. There it is. Area equals 6 25/100 centimeters squared. That's number 8. Take a look at number 9. Again, another box. We love these things, right? It says match the expression on the left with its product. So once again, I'm just going to solve each one, starting with the first one. 3 4/100 times 10 squared. That means I'm moving my decimal bloop, bloop, 2 times. That's going to equal 304. And look, there's 304. Next, I'm going to take 304 thousandths times 10 to the 4th power. So I'm going to go 1, 2, 3, 4, add a 0, right? That's going to equal 3,040. And there's my answer. Next, I have 3 4/100. I'm going to multiply that times 10, which means I'm just moving it over once. Should have done that. We end up with 30 4/10. And finally, we have 304 thousandths multiplied by 10. Move it over one time. We end up with 3 4/100. So that's, again, not too bad. Not too bad at all. Let's move on. Take a look at number 10. It says select all the expressions that are equal to 9/100 times 4/10. I'm going to start off by actually solving that. 9/100 times 4/10. There we go. So I'm going to ignore decimals. 9 times 4 is 36. And I'm going to add in my decimal again. There's 3 spaces, so 1, 2, 3. My decimal goes here. I'll fill in with a 0. I'm looking for all of the equations here that equal 36/100. So let me walk my way through it again. I've got 9/100 times 4/10. So again, cross-simplifying is your friend. 4 goes into 4 once. 4 goes into 125 times. Now I have 1 times 9, and I have 25 times 10. I get 9 over 250. I want to convert that into a decimal, so I'm going to divide. 250 is going to be my divisor. 9 is my dividend. I'm going to add a decimal and a 0. 250 doesn't go into 90. I'm going to add another 0. Now 250 does go into 900, right? We'd probably guess that it goes in there 3 times. I should have added my 0 there. Okay, now 3 times 250. I'll kind of do the math rather quickly here, but again, don't be afraid to do the math on your own off to the side. We'd end up with 750. I subtract. That's 0. I'll borrow. That's 5. That's 1. We get 150 left. Add another 0 because we keep on going. We don't want remainders. Guess I need to move this up so you can see it. Always helpful to see, right? So now we have 250 going into 1,500. It goes in 6 times, and 6 times 250 is 1,500. We get our answer of 36 hundredths. Take a look up here. That's what we're trying to shoot for. So it turns out that our first option is correct. We could try it again now with our next one. Let me erase this stuff here. And let's try the next one. It says that it is 4 hundredths times 9 hundredths. Again, cross simplification. It's going to make your life easier. 1 times 9 is 9, and 100 times 25 is 250. Do we need to do that again? It's the same problem we just did, right? 250 going into 9. Turns out that one's going to be correct as well. I think in my book here, they marked that one as not being correct, but it is correct. The next one we see here, it says 9 tenths times 4 tenths. Let me write that one out. Again, cross simplification is great. So 4 and 10 both have a common factor of 2. 2 goes into 4 twice. It goes into 10 5 times. Now I have 18 over 50. Now to turn that into a decimal, I'm going to divide. I have 50 and I have 18. Now 50 doesn't go into 18, so I'm going to add that decimal and that 0. 50 does go into 180 3 times. That'd be 150. I'll subtract and get 30. I'll add a 0 and bring it down. 50 goes into 300. That'd be 6 times. And that would be an even 6 times. So we get a remainder of 0. Now look, we were looking for 36 hundredths. We got 36 thousandths. We got 36 hundredths. So this third one would not work. Not going to happen. It's off by just a little bit. But it's important that we did the math to figure that out. Let's move on. Take a look at the next one here. It says 4 tenths times 9 hundredths. Let's write it out again. Now again, cross simplification. 4 goes into 4 once. 4 goes into 125 times. 1 times 9 is 9. 10 times 25 is 250. At that point right there, we should know that works out. We've already done the math to know that 9 over 250 checks out each and every time. There's one left, and that is 40 over 100 times 9 over 100. Let's try that one out. Again, cross simplification is always a good idea. In this case, 40 and 100 both have common factors. We could say 20, right? 20 goes into 40 2 times. 20 goes into 100 5 times. Now 2 times 9 is 18, and 100 times 5 is 500. So 18 and 500. In fact, I think we already did that math, if I'm not mistaken, and we figured out that was not working. Unless, did we? I can't remember now. Well, let's do it. Why not? So I have 500 as my divisor, and I have 18. Obviously, it doesn't work. I'm going to add my decimal, my 0. 500 doesn't go into 180. I'll add a 0. 500 does go into 1,800 3 times. 3 times 500 is 1,500. My goodness, I'm glad that I decided to do this because I don't think we did this yet. Add that 0 and bring it down. Look at this. I'm bumping into my last question. I thought I'd be all high-tech with this tablet, and I think it's kind of not working out so well for me, but that's all right. All right, so we have 500 going into 3,000. It certainly does go into 3,000 6 times, evenly. So look, 500, or 118 divided by 500 is 36 thousandths. That's the number we were looking for here. So that last one does check out. Number 10, another one that could potentially take some time to solve, but with a little bit of work and some mathematical skill, we can solve that one pretty easily. All right, take a look at number 11. It says 1 glass of lemonade has 115 calories. How many calories are in 3 5/10 glasses of lemonade? Write an equation to model your work. Well, we can do that, right? So we know that there's 115 calories in one glass. We want 3.5 glasses. We're just going to take 115 and multiply times 3.5. So 5 times 5 is 25. 5 times 1 is 5, plus 2 is 7. 5 times 1 is 5. Add my placeholder 0. 3 times 5 is 15. 3 times 1 is 3, plus 1 is 4. 3 times 1 is 3. Add them together. That was weird. We're going to end up with 5 plus 0 is not 0. What was I thinking? Put a 0 there. Shame on me. 5. 7 plus 5 is 13. 4 plus 1 is 5 plus 5 is 10. And 3 plus 1 is 4. Now you might think it's 4,035, but not so fast. There's one decimal place here, so we need one decimal place here. Our answer is 403 and 5/10. Let's move on. Wait, did I make a mistake? I did. Look, 7 plus 5 is not 13. What was I thinking? That should be 12. Our answer is 402 and 5/10. Can't believe I'm making these silly mistakes. Good thing I'm double checking my work, right? And something you can do as well. Take a look at number 12. Natalie likes to mail lots of postcards when she goes on vacation, and who doesn't? In 2014, the cost of a postcard stamp was 34 cents. Natalie buys 10 postcard stamps. What's the total cost of the stamps? Check it out. We just have 34 cents times 10. We know when we're multiplying something by 10, we're just moving the decimal over one space. That's going to be 3.4. But remember, we're talking about money here, so we want to make sure we include that 0. So the cost of the stamps is $3.40. We wouldn't really say it's $3 and 4/10 of a dollar. We just say $3.40. Take a look at part B. Natalie and her friends decide to buy 100 postcard stamps. What will be the total cost of the stamps? So we're going to take our 34 cents, multiply it times 100, which means we're just moving that decimal over 2 times now. That means our cost is 34. Now we could also phrase that as $34.00. That would also be true for part B. Let's take a look at number 13. Hey, look, we're back again with one of these awesome grids. They're so amazing, right? Why not do them some more? It says, without doing the multiplication, match each expression on the left with the correct product. Use number sense to help you. So your number senses are tingling. We're going to try to do this without using multiplication, right? And at first you may think, well, this is impossible. I need my multiplication. You don't really need it. Now, I will say, if you're somebody that has to rely on it, I won't be upset or terribly upset that you're doing that. But we have 8 and 32 hundredths times 1 and 15 hundredths. Just think that through for a moment, right? We're taking basically 8 if I round it times basically 1 if I round it. We're going to get a number that's really close to 8, right? But we have underestimated because we rounded down. So we know our answer is going to be above that whole number of 8. Any chance it's going to be 19, 29, 2, or 9? One of those answers probably sticks out in your head. 2 is way too low. 29 and 19 are way too high. Our correct answer is 9 and 568 thousandths. Didn't even multiply. Take a look at the next one. We have 5 and 78 hundredths times 35 hundredths. Now we know if we're multiplying a number that's by a number that's less than 1, that number is going to get lower. So we're expecting a number that's smaller than 5 and 78 hundredths. There's actually only one option on here that's smaller, and that is 2 and 23 hundredths. Take a look at the next one. We have 6 and 12 hundredths times 4 and 85 hundredths. Again, if I round, I'd get 6 times 5. Now 6 times 5 is 30. Is there a number up here that's close to 30? Look, there it is, 29 and 682 thousandths. And finally, if you've done them all right, there's only one option left. Well, let's take a look at it. 7 and 95 hundredths times 2 and 48 hundredths. I could probably round that up to 8, and maybe this round it to 2. 8 times 2 is 16, so we're looking for a number that's close to that. We might even round this to 2.5, right? So we know we're looking for a number that's close to 16, but it's going to be more than that. It's going to be 19 and 716 thousandths. Guys, this is a lot of questions. We're almost there. We're on to our last page. We've got Derek. Derek runs 2 and 25 hundredths miles each day. How many total miles will he run after 10 days? And explain. I almost feel like we don't need to write this one out, but I'm going to anyway. We've got 2 and 25 hundredths. We're multiplying it times 10 because there's 10 days. I just move my decimal over. It's going to equal 22 and 5 tenths. 22 and 5 tenths miles are what he's going to run in 10 days. Anytime I'm multiplying by a power of 10, we're just moving that decimal. Take a look at number 15. It says select each equation that the decimal 65 hundredths makes true. So check it out. All of these are powers of 10. So I'm going to take that number, 65 hundredths. And each time I'm considering what I'm doing, I'm going to move it over 2 times. Look, 1, 2. That's going to give me the number 65. That would be correct. Next, I'm taking 65 hundredths times 10 to the 4th power. I'm going to move it over 1, 2, 3, 4. I'm going to fill in those blank spaces with zeros. I'd end up with 6,500. That's not true. Okay, take a look at the next one. We have 10 to the 1st power. Remember, 10 to the 1st power is just 10. So I'm going to move it over 1 space. If I move this over 1 space, I do indeed have 6 and 5 tenths. Next up, we have 10 to the 3rd power. Keep in mind, I'm going to move it over 3 times. Right? 1, 2, 3. I'd have a 0 there. It wouldn't be 65, it'd be 650. So that one is unfortunately incorrect. The last one, we have 10 to the 1st power times 65 hundredths. Again, I'd move it over 1 time. That would give me 6 and 5 tenths. That's bad handwriting, but you get the idea. Not 65. So unfortunately, we can't pick that last one either. Moving on. Now, my book obviously has been used, so it's got some coloring in it. But it says, a farmer plants 4 tenths of a field with wheat. The field is 2 and 3 tenths acres. Shade the grids to model the multiplication. What we would do is we would shade in 4 tenths, like going maybe this way, and then 2 and 3 tenths going this way. And it's actually been done for me, so I like what they did. They've got 4 tenths, right? 1, 2, 3, 4 of those are shaded in all the way across. And then they have 2 and 3 acres. There's 1, 2, and then 3 tenths shaded this way. So that shows us then that, that shaded model. And then part B, we can use that model if we want to, or we could just multiply how many acres are planted with wheat and use an equation to model and explain. So we can certainly do that with the equation. We have 2 and 3 tenths. We'll multiply times 4 tenths. And we'll just multiply like we're used to. We're going to ignore the decimals. 4 times 3 is 12. 4 times 2 is 8, plus 1 is 9. And I don't really need that placeholder 0. I got excited there. I would just get 92, but then I have 1 decimal space, a 2nd decimal space. So I move my decimals over. And my answer here is 92 hundredths. 92 hundredths of an acre will be planted. Now, if you look, they got the wrong answer here. And I'm not sure the math, what they did to get that, because obviously we should have a 9 there, not a 1. Some people look at that and they get confused because they start off with 2 and a third acre, or 2 and 3 tenths acres. Remember, we're multiplying that by a number that's less than 1. So we are indeed going to get a number that's less, or we're getting smaller. Look at number 17. It says Bradley walks 6,500 hundredths miles each Friday to his friend's house. He takes a different route home that is 1 and 2 tenths miles. How many miles will Bradley walk to his friend's house and back in a year? And it says, remember, there's 52 weeks in a year. Glad they pointed that out, because maybe if we didn't know that, this would be a tough one to figure out. So each Friday, Bradley is walking 6,500 hundredths plus 1 and 2 tenths. Easy for me to write. 1 and 2 tenths. I'm going to fill in that 0 and just add these numbers together because I've lined up my decimals. 5 plus 0 is 5. 6 plus 2 is 8. Drop the decimal down. And 1. That means every Friday, Bradley is walking 1 85/100 miles. Now there's 52 Fridays in a year. So I could take 1.85 and add it 52 times, or just multiply. So I'm going to rewrite this as a multiplication problem. Again, I can multiply by just ignoring the decimal. So 2 times 5 is 10. 2 times 8 is 16, plus 1 is 17. 2 times 1 is 2, plus 1 is 3. Add a placeholder 0. 5 times 5 is 25. 5 times 8 is 40, plus 2 is 42. And 5 times 1 is 5, plus 4 is 9. Add those partial products together. 0 plus 0 is 0. 7 plus 5 is 12. 3 plus 1 is 4, plus 2 is 6. And 9. I get 9620, but wait, don't forget your decimals. There are 2 spaces after the decimal, so I need 2 spaces after my decimal. That means that Bradley is walking 96 2/10, or we could say 20/100 miles each year. That's crazy. Bradley is really committed with visiting his friend once a month. That's number 17. Let's move on to number 18. So the last question, guys. We did it. Alyssa paints 3 walls blue. Each of the walls is 8 3/10 feet tall and 7 5/10 feet wide. So letter A here says, round the length and the width to the nearest whole number, then estimate the area that Alyssa will paint. All right, so no problem. Remember, area is just length times width. So write this down here. We're going to round. 8 3/10, we'll round that to 8. And then 7 5/10, we'll round that up to 8. 8 times 8 is 64. That means for letter A, she's going to paint about 64 square feet. We can write feet squared, right? For letter B, it says find the exact area. Oh my, okay. Well, no problem. We can do that. We have 8 3/10 times 7 5/10. So 5 times 3 is 15. 5 times 8 is 40, plus 1 is 41. Add a placeholder 0. 7 times 3 is 21. And 7 times 8 is 54 plus, or sorry, 56 times 2, yikes, is 58. We'll add that together. 5, 2, 12, and 6. Don't forget your decimals. There's 1 space, 2 space, 1 space, 2 space. We end up with 62 25/100 square feet. Okay, and then finally part C, compare your estimate to the exact answer. Why is your answer reasonable? Well, our estimate was 64. Our answer is 62. We could probably explain that in writing by saying that we overestimated. Remember, we rounded 7 5/10 up to 8, and we took 8 3/10 down to 8. Overall, our answer here is going to be higher or bigger than our actual answer because of the way we estimated or rounded those numbers. Whew, man, that was a long practice assessment, but it was totally worth it. Oh no, there's more. Oh my goodness. I kind of fooled myself there because I was thinking we were on the last one, but we weren't. That was just the second to last page. On to number 19. We have Letitia and Jamal at a bakery. There's a bagel, a muffin, a fruit pie, and it says Jamal wants to buy 6 muffins. How much will this cost? Well, look, we're just going to take the price of 1 muffin, which is $1.99, and we're going to multiply it times 6. So I'll just go 6 times 9 is 54. Oops, I lost my page. That's not what you want. Let me start that again. Okay, 9 times 6, still 54. 9 times 6, 54, plus 5 is 59. And 6 times 1 is 6, plus 5 is 11. 2 decimal spaces. That means that Jamal's going to pay $11.94 for his 6 muffins. Letitia wants to buy 12 bagels, and she uses partial products to find her total. So we really got to pay attention to this paper here. She says $16.80 is close to my estimate of 12 times 1 equals 12. So this is totally reasonable. And do you agree? Look, she says 12 bagels at 95 cents each. She rounded the bagels up to 1, and she came up with her answer of $12. She used some partial products here, taking 10 times 5 tenths to get 5, 10 times 9 tenths to get 9, 2 times 5 tenths to get 1, and 2 times 9 tenths to get 1 and 8 tenths. She added all those together and got $16.80. This is one where almost it depends on your reasoning. You could explain that in a way that would be true. You could also explain that in a reasoning that didn't make any sense and not get points. So kind of be careful on something like that. All right, we're on to the last two questions. Here it comes. The area of one fabric square is 4 85 hundredths square inches. What's the area of a quilt made with 10 to the second power fabric squares? So we're going to take that 4 85 hundredths. If I multiply that times 10 to the second power, remember I'm just moving that decimal over 2 times. That means that we're going to have 485 square inches. There's a question that's not too hard, right? And we can explain that because we just multiplied the numbers together. Remember, 10 squared is the same as saying 100. Last question, on to Jen. Jen bought 3 72 hundredths pounds of apples at a farmer's market. Andrea bought 4 times as much as Jen. Look, we've got a nice little tape diagram here. We know Jen bought this much. Andrea bought 4 times that amount. It says which expression represents the problem and use the bar diagram to help. Look, we could take that amount times 4 times 1 divided by 4 or divided by 1. It makes the most sense to actually multiply it. And then finally, letter B, how many pounds would that be? So we're going to take $3.72 times 4 with a simple multiplication problem. So 4 times 2 is 8. 4 times 7 is 28. 4 times 3 is 12, plus 2 is 14. Add our 2 decimal spaces, and we get our answer of, see how kind of sliding around, $14.88. Guys, that is our practice assessment. Yikes, this is so much work that we just did, right? This video is like 48 minutes and some seconds long. Crazy. We want to make sure that you can do this. So again, use the video to your advantage. Practice, practice, practice. It makes perfect. And these are the types of questions you can expect to see on your Chapter 4 test. I hope this was helpful. I hope you can review it and it will help you. Have a fantastic day, and I will see you soon.